So, welcome, Jatin. Really excited to have you here at Building It Big. Would you mind just kind of giving us a quick introduction about yourself and let's just take it from there?
Of course. Thanks, Stress. We've known each other for a while now, so happy to do this. Yeah, I am a computer engineer from Vellore Institute of Technology. I completed my bachelor's in computer science in 2016. Soon after that, I during my last semester I was an intern at Carnegie Mellon, and then I got a job offer at Carnegie Mellon as a research associate. So I was working at CMU for a while, and while I was working, I was able to do some courses on the side. So I essentially completed my master's at CMU in robotics. My main focus was AI reinforcement learning applied to robots and how to accelerate reinforcement learning. Right after I got out of my master's program, I co founded a startup called Bloomfield Robotics that's still going. We basically do computer vision in agricultural fields. Uh, I did that for a while. After that, I used to work at Amazon for about 2.5, 3 years in the Amazon Scout project, which we'll be talking about more, I think, in the interview. And currently, I work at Diligent Robotics. I'm a staff software engineer and I work on similar, so perception, computer vision at Diligent Robotics. And we basically make robots for hospitals, which help out nurses in the hospitals and do
That's
delivery
that's
in
really
hospitals.
that's super
Yeah,
amazing and super interesting. And of course,
yeah, it was too
we've
long, but yeah,
no, for
it's
sure,
good.
man.
I'm
Like, I
sorry.
mean, we've definitely done some bit of cross what do you call collaboration in the past, but I mean, I'm so
Nice.
glad and so happy to see you come such a long way. So as you of course
Same,
hinted,
likewise.
thank you. So as you of course hinted, we'll definitely dive more into the Amazon robotics piece. So just to kind of begin that front, can you tell me a little bit about like what is Amazon Scout? And I understand like robotics, of course, is used in Amazon in several arenas, right? But this, of course, is like in the e-commerce delivery space. So can you just kind of like talk to us a little bit about like what is it?
Yeah,
What does it do? Yeah.
yeah. So Amazon Scout is a project. It's a fully electric delivery system, and the idea is to automate last mile deliveries. Right. So if you can imagine, right now, someone delivers your packages to your doorstep. Right. Can you get automated small vehicle to do it? So Amazon Scout is essentially a small. Think about it as a water cooler sized vehicle with wheels on it, and the idea is to do last mile delivery for your regular Amazon packages, but especially things that are time critical, right? So your Whole Foods deliveries or Amazon Fresh orders that need to get out quickly. So the idea is to automate that process. Also, Amazon has this commitment to be net carbon neutral by 2040. So having a fully electric delivery vehicle for the last mile delivery also pushes that goal forward. So yeah.
That's good. All right. So you mentioned, of course, a lot of things right there, right? Last mile delivery, and then you mentioned robotics, and of course, like the carbon neutrality because of electric vehicle and stuff like that. So let me pick like one by one, right? So first of all, we spoke, of course, what is like Amazon Scout, but then can you talk to me in terms of like timeline? When did Scout program begin? Um, when did they first put a robot out in the market for last mile delivery? And within this frame, like when did you join and what did you see as a cycle, right? Like, so just kind of like pointers, like I don't know,
Yeah, of
2019 is
course.
probably when they began, right? So if you can
Yeah.
begin from that.
So Amazon Scout began on the first robot that went out was
Yeah.
in Squamish in January 23rd, I believe, 2019, as you pointed out, right? I
Hmm.
joined in late. So I joined in September 2020, I believe that's correct. So I joined in September 2020. So it was already by the time I joined, like I wasn't there for the launch. There were a bunch of these delivery vehicles robots out in the field already. So yeah,
Joined, Jatin, was there like a point A to point B solution already happening on that robot, or was it not really there? Like, had they gotten a launch out wherein, say, if Amazon wants to send me a package in Washington, can they do that or
yeah.
not?
No. So the reason they were expanding the team and where I joined was like when I joined, basically the team was relatively small, and the idea is like uh, they had they had a proof of concept, but like they had to figure out scale yet. So you had to figure out like how to, you can, okay, you can do it in your neighborhood, a neighborhood that you have mapped out extensively, right? But can you do it? It's the same problem as self-driving car industry, right? And there are
Right.
a lot of parallels there, which is the idea is that, yeah, the proof of concept has been proven for a while, but like, why do these companies have 5,000 employees? Well, it's because like you want to scale it. Can you do it in India? Can you do it in parts of Africa? Can you do it in UK? Can you do it
Yeah.
outside of SF essentially? So
Yeah.
yeah, that was the point. Like, how do you
Yeah.
generalize scale up the solution?
Got it. Got it. So you brought up the point of teams here, right? So I just wanted to like dive deeper in terms of teams. So just like at a broader, higher level, what was the general split, right? Like I presume there's of course a hardware team and a software team to begin with,
Yeah,
right? But like say, what were broadly the team, the makings of a team, and what kind of profiles were there? Like say within hardware, what kind of engineering profiles? Within software, what kind of profiles? How were they talking to each other? Where's the merger? Kind of stuff, right?
yeah. So again, like this is not just Amazon Scout, but like I have had the opportunity to work in several robotic space, right? Like that's the space I work in. So this is a very typical split, which is that your hardware team tends to be a bit smaller. So it would be like basically like about 30% if your software team is rest of 70%. Like that usually is the split. Hardware teams are smaller. Uh, but and there is communication with the hardware teams in the sense that uh, the issue with any self-driving vehicle right now, and this is also in some sense a self-driving vehicle, right? Even though it
Yeah.
operates on a sidewalk, it's a small robot that goes on a sidewalk. So the challenges are in somewhere, in some sense bigger, in some sense smaller, right,
Yeah.
than self-driving vehicles. But the key issue, that the key part that still has to be figured out in all robots is autonomy, right? Like how to make these autonomous. The hardware exists and the hardware has existed for a while, so the software teams always tend to be bigger. Now in any robotics software team, of course there is like your ops teams and your platform teams that take care of your cloud solutions, right? And how the data gets uploaded. But like I work in core autonomy. So any robotics core autonomy team essentially has four pieces, right? So the four pieces are perception. So which is where I work, and which is what I love the most. But the idea is that you have all these sensors on your robot or a self-driving car. How do you make sense of them, right? Like you're just getting a raw camera feed, a raw radar feed, a raw lidar feed, but like you have to make decisions on that. So the idea of the perception team is to help you understand the field, like how to semantically understand what's going on in the world around you, uh, using those sensors, right? Then there is always a navigation team. And the navigation team's idea is like you take perception as input, right? So you take basically your perception tells you what's around you, but now you have to plan a path and you have to execute on it, right? So you have to basically plan how to, which direction you're going, what is the shortest route, while making sure that safety is adhered to. There are road rules that are adhered to, right? Then there is a localization team. Localization team is essentially, it tells you where you are in the world, right? So your GPS is a localization system. It tells you like there is a map of the world. Where are you in the map of the world? But like it's more complicated than that, because as we all know, GPS is not accurate or reliable, right? So yeah, like you need, if you're making split second decisions, you need more precision than what a GPS provides you. So
Yeah.
there is that
I
team. And then the last one is manipulation team. So if you're trying to basically, which Scout does not have, but like if you're trying to manipulate things around you, so pick up objects, open doors, things like that. So yeah,
got it.
Scout does not have that. But I
Got
was
it.
a part of the perception team, and yeah, long answer to get to the point. But I wanted to take the opportunity to explain the split on how
No,
robotics in
I
general
appreciate
works.
that. I appreciate
Yeah,
that, and we are definitely trying to unpack all of this, right?
yeah,
Not from a delivery robot, but definitely from the
yeah,
package as well. So yeah, and the next thing which I really wanted to touch upon was like so having done product development myself quite a lot, right? We always begin from say a hypothesis or a core user need and a user problem, right? And you did touch upon this when we started talking about like of course Amazon wants to be carbon neutral and all of that, but what was the bigger like problem, or like say what is the core issue that Amazon saw for which they wanted to have an autonomous robot for delivery?
Like I said, like last mile deliveries are the most expensive piece, right? Like they are really expensive. And then the idea is like they also burn the most amount of uh, they have the most amount of emissions, right? And in certain case now, as we know, the world's getting quicker and quicker, right? Like I want my packages as soon as I ordered it, right? And there is like a human element to like everything. Like
Yeah,
for example, if you're ordering groceries, there is you can't take too long. Otherwise, the whole purpose of it is defeated. So you need to get it fast as fast. So having someone always there, like having a human ready to go, is basically becomes infeasible if you're trying to scale and you need an automated solution.
got it. Okay. So we, of course, through several things, you did mention a word quite a lot, autonomous, right?
Yeah.
And I will not embarrass myself by saying that I know of it, but I definitely want
Okay.
to put you on spot and saying, okay, can you explain us, Jatin, what is autonomous? And like just in like very simple terms, so that someone
Yeah.
with
Yeah.
like 5-year-old brain like myself
Yeah. Yeah.
gets it,
Yeah.
right?
Like myself. Yeah. Autonomous is essentially means that it can operate on its own with no external human intervention. Right. That's what it means in a robotic space, or like in even a self-driving car space. Right. So fully autonomous means that no human has to intervene at all. The you give a robot a task, which is to go from point A to point B, and it just does it. Right. That's the idea of autonomy. Because you can
Right.
have a solution, you can still have like a robotic solution, right?
Yeah.
Where you can be joysticking the robot, right? But just if human still being involved in it, it still doesn't scale for the same reasons that deliveries don't scale, right? So autonomy is really important. By that I mean like the robot's able to do it with no human intervention.
Yeah.
Yeah.
So one thing which I was thinking, right, while you were just saying about talking about autonomous, I get the point of like no human and like say, of course, like send it out, right? But there are some alternatives in the market, like say you could have a drone delivery, right? And if I'm not mistaken,
Yeah.
Amazon's probably piloted that as well,
Yeah.
right? I'm
Yeah.
not
Yeah.
sure what's the status,
Yeah.
right? The other one, which is quite common, especially say in healthcare or like previously in meal deliveries, was pneumatic tubes, right? So you send something up a tube, and then of course it reaches. Did you ever like look into any of this, or while you were a part of the team, did the team like explore, okay, if not autonomous robots, could we do something different?
Yeah. So why so Amazon also invests in drones heavily, right? Like
Yeah.
this is well documented. Amazon Prime Air is the team there, which is a huge team, and I
Yeah.
have a lot of colleagues who work there. uh, there are drones, and it's a situation of in some sense hedging your bets, right? In the sense you want to provide a solution which needs as less of new infrastructure as possible in the world, right? Because anything that needs more infrastructure, more permissions, is harder, right? So your idea of pneumatic tubes and things like that, right? Like if it requires extra dedicated infrastructure, right? Which is a huge undertaking, because how many hoops do you have to jump, right? With the idea of the robots and a sidewalk robot is that you need no new infrastructure, right? Like that thing doesn't exist.
Yeah.
So that problem doesn't exist, and that is a problem that no private company controls, honestly, right? Like
Yeah.
you don't control infrastructure. You can lobby
Yeah.
for it and things like that, but like uh, yeah, you
Yeah.
don't control it. The thing with drones is, yes, drones is a very lucrative way of doing it, and that is being explored widely. There are plenty of other companies that do it. The issue with drones often ends up being with payload. Like drones are basically, they're very power hungry, right? And as the payload increases, the drone's time to operate decreases significantly with the payload, right? So if you're trying to carry something that's whatever 10 kilograms, uh, your drone does not have a battery unless you have a ridiculously huge drone, right? Like the battery capacity. And a ridiculously huge drone is very noisy, hard to produce, So like also like you don't want to disturb the neighborhood. Like I shouldn't have a plane land in my
Yeah.
in my yard. So I,
Yeah.
I love drones, and drones are excellent, but there are limitations to it, which are just
Yeah.
physical.
No, I mean it's fair, right? And
Yeah.
you at least have a backyard. I don't even have one.
Yeah,
So
but
that's an
yeah,
interesting
that's the
problem.
point. Yeah.
Uh, yeah. So again, you spoke about perception, Jatin, when we were kind of like building up to the autonomous development, right? Um, Again, same question, right? What is perception, very simply put? And then can you talk a little bit about why perception and like what exactly do you do in that?
Yeah. Um, Perception, very simply put, is you can put cameras or any sensors on any robot, right? But someone has to consume that sensor feed and make sense of the world using those sensors around you in a timely fashion, right? Like all these core pieces are important. So first of all, it is important, like a camera just shows me there is a dog in front of me, but like I use my intelligence. That's where the artificial intelligence piece comes to it, right? To understand that, oh, it's a dog in front of me, it's about to move or it won't move, it looks like it's going to move, things of that nature, right? So someone has to consume the raw pixels, the raw RGB pixels, and make sense of it, in coalesce that information in a way that you can make decisions on, right? So that is largely perception's job, and you have to do it quickly, right? Because there are things which are safety critical, like you can't take forever to make your decision, so it has to happen instantly.
Yeah.
So
Okay.
yeah, that's
So
largely
then,
perception.
and then if I just get that right, like I mean, if I were to like kind of say simply paraphrase it back to you, when you have a sensor on a machine, whether that's a robot or whatever, right? It is essentially capturing feed, which could be images, which could be pure data, could be metadata, any of those things. So a system which essentially makes sense of all of this information is perception system, correct?
Exactly. Perfect.
Okay.
Yep.
I'm learning fast.
Yeah.
Now, of course, we spoke about perception, and you mentioned things like whether that's a dog or there could be a pole, like a stationary object or a movable
Yeah.
object, whatever that might be, right? So, end of the day, like it is essentially a 3D object, right? So, what exactly do you do when you see a 3D object? And is there like a logic that you code out of it, and how do you do that, right? So, if you could explain a little bit on that.
Yeah. So one of the core things I worked on when I was with Amazon Scout was dynamic object tracking, right?
Hmm.
And the idea, like, the it speaks for itself. But the idea is like to track everything that moves around you, right? Because those are things in some sense that are more important and more time critical, right? So dog is one thing, the cars around you, the humans around you, right? Uh, like these things need to urgently be adhered to and responded to, right, in a certain way. So dynamic object tracking is essentially encompasses all of this. And the idea is like you and by what is dynamic object tracking? It means that in 3D, defining the position of all dynamic objects with respect to you. So, if you are the coordinate frame, right? Like I am the world, I am 0, 0, 0 in Cartesian coordinate system, right? In my coordinate frame, where are these things, right? Like where is it? What is its orientation, right? So, like not just what is its velocity that I have observed so far, and how do I predict that velocity? Like what its velocity is going to be, right? So all of this is dynamic object tracking, and then you make a decision based on like, do I have to change my path to accommodate this object? And answer in case of a robot is like almost always yes, right? Because you are a second class citizen, if I may say so, right? Like people are more important than you if you are in a sidewalk, so you always have to basically make sure that you make way for them, or you go increase your speed, decrease your speed, and in any case never collide with them, right? So
Yeah.
essentially that's what dynamic object tracking deals with.
Yeah. And I'd say probably that's true for living organisms and not just
Yeah.
living, moving organisms, right? Like not trees, but
Right.
essentially even a pet for that matter. You have to, of course, make way for them as
Of
well.
course. Yeah.
And I think one important aspect or question just that comes to my mind here is how do you identify whether or not this object in front is living or not, right? And I'm just thinking probably an edge case, but whatnot. Like, what if there's a toy, right, which looks like a dog? So how do you know, and how does the algorithm like understand that?
Yes. So basically, this is where the AI piece comes into the picture, right? And we have like my manager, who's excellent. His name's Todd Hester, who was a applied scientist manager, previously worked at DeepMind. He basically gave a great talk at ICML last year, or maybe the year before that, where he dives deeper into like how we do it. But the idea is like that's where the AI piece of it comes into the picture, right? You basically use neural networks that you get annotations for the data, where this is a dog, this is not some human annotates is. Then you train AI model, whatever your favorite, latest, greatest model is. It used to be CNNs, it's transformers now. So you train those models to identify these objects. I will say, like, I was going to bring this up later, but like, there are funny cases where, like, we used to see our models fail for weird reasons. The one that comes to my mind is during Halloween's, our robot, we had a sidewalk robot, right? Like I said, it goes on
Yeah.
sidewalk. And during Halloween, it stopped moving in a case because there were skeletons in people's yards and it thought they were humans trying to run, right? So it stopped. So yeah, things like that happen. Uh, yeah.
Very interesting. And
Uh,
just out of curiosity, like what do you guys do then?
you essentially train for it. You say that you
Yeah.
basically explicitly add those data sets, you prioritize learning on those and say that, yeah, these are not humans.
And do you do that on a timely fashion, like only in Halloween? Or
No, I mean, no. Now this is a unique scenario, but it's part of your
yeah,
data set and forever. Like it's
right.
part of your data set forever.
So if you ever see a skeleton, you're gonna run over it, essentially.
No, the idea is don't assume it's human and don't assume it's moving, no
No.
matter what
Okay.
pose it's in. Yeah.
Yeah, no, that's great. Okay, so you touched upon AI, right? And again, as you said, you wanted to take this on. So yes, let's dive into this, right? So again, so we spoke about perception, which is the object tracking sort of a scenario, and kind of telling the robot, here's the object, do something, right? Whether that's like move your 2D coordinates, or whether that's like stay put and like continue on the existing pathways which you have defined,
Right.
right? And then of course like AI comes into picture, where it is kind of like looking at the annotations, learning from the data set, and going forward, right? Can you talk a little bit more about like what exactly were the makings of the AI team, what exactly were they looking for, and what kind of models, right? Of course, transformers are the talk of the town. How much of that was being used, not used, all of that stuff?
Yeah. So again, basically we had I like the team size changed with essentially the perception team had two components. Half of it was in Germany, half of it was in the US. The team in the US, which I was a part of, was usually between like 10 to 13 people, something of that nature, and like new people join, some people move on, so it changes a bit, but that's kind of like 10 people is generally ballpark you can think of. And yes, we were using and again, like I said, there's a ICML talk that my team's manager gave on this, but yeah, we were using the latest, greatest transformers and even improving on that in the sense that like you use different camera feeds, you use you enhance the transformer such that it can accommodate for different sensors simultaneously, not just cameras, and then it can take in several cameras simultaneously, right? So most of the results that you see today in the field are one camera at a time, right? Like most of the publications that you see, but one camera will never give you a 360 view, so you got to increase its capacity and make sure that you're capturing the whole 360, and you have more sensors. You don't have just cameras, you have other sensors, so building those in. So yeah, it was transformers that we were using, but a lot better version that the team had developed in-house. Yeah.
Got it. Okay, so now we've looked at like kind of like say the underlying concepts of what makes this robot, right? So let's dive a little bit on like the actual development and testing and all of that stuff, right? So when you guys like develop a product like this, and essentially from a software piece, so what are say the different types of tools which are used, environments that are used, and yeah, if you could just talk a little bit about that one.
Yeah. So essentially, we had a in-house simulation environment that you use initially, right? So look at it as a game engine, but tailored for robotics, right? So like
Yeah,
you can basically initially build your algorithm, test them in game engines, but there are limitations to that, of course, right? Like no game engine can truly, like it's very hard to truly represent the physics of the world, right? And the unpredictability, uncertainty of the world, right? Like
yeah,
it's hard. Or game engines are too perfect, as you can say, right? Like everything's just perfect in engine. There is no noise. But in real world there is a lot of noise, in the sense that there is sensor noise even, right? There is
yeah,
noise to that low level, and there are sensor limitations, right? So then you go out and you collect a bunch of real world data, and you create a benchmark from that real world data, right? And you say
yeah.
that every release that goes out from now, I'm going to test against this benchmark, and it has to be strictly better than what I was before, right? Like, so there are, I can talk about dynamic object tracking, but like there are, for dynamic object tracking, like state of the art papers would compete on MOTA, which is mean object tracking accuracy, right? Like that is the metric which is the industry standard. Uh, so it is essentially, it's what publications and people try to outdo each other and compete on.
Yeah.
So yeah, you use metrics like these. You have an in-house data set, and you make a benchmark. So you make a evaluation benchmark, and you say that every release that goes out needs to be better than the previous one. That's the idea. Yeah.
So, say PM speak, is North Star metric then still Mota for the team? Is that what you guys look at?
Uh, So initially it is, right? But then, as you can imagine, like MOTA is a very generic metric, because it doesn't encompass, it's not about, it doesn't take care of your use case, right? Like it is a general object tracking academic metric, which is really important. But
Hmm.
but like there are certain things that are more important in your use case, right? In the sense that objects that are close to you are more important, right? Because there is a higher probability you can hit them, or you have to make way for them, right? So you don't just use academic metric. You say that
Yeah,
no, 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 no. Let me break this down into things that are more important to me. I can still use this metric, but I can do some weighting, right? Like this is an absolute critical piece. This is a nice to have. This is, yeah, a very nice to have if I don't have it. So yeah, you break it down, but the idea is that yeah, you still have numbers, and you say
yeah,
that I have to improve of those numbers, and it's important to agree on those numbers beforehand, before you start developing, so that like you don't overfit in some sense. Yeah.
got it. And again, I think you mentioned the concept of benchmarking, which I think is again key, right? Like end of the day, this is what it
Yes.
is. You have
Very.
to be above X threshold to even be a release candidate or something which can be shipped
Right.
next.
Right.
Okay. So and were these all like in-house tools for Amazon to where you would say write code and stuff like that?
Yes, these were all in-house
In-house.
developed tools. Yeah. Yeah.
Okay.
Yeah.
And
Very
and
much.
what language would you code in primarily?
Yeah. Both Python and C++.
And when you talk about like say now production level code which actually is on the robot, right, like which is on the road now, can you talk a little bit more about like how often does the release happen? Is there like a weekly thing, bi-weekly, monthly? What is the cadence essentially, right? And
Yeah.
what how often do you figure out, oh, something's like malfunctioning or not appropriately acting, right?
Yeah. So I guess, like I mentioned, your release cycle is, again, like you try and keep it as fast as possible. So you try and keep it to a cadence which is definitely not monthly, so earlier than that, right? Like bi-weekly, or you aspire for that. How often things happen? Essentially, like I said, it was important for us to have the benchmarks. Like I said, have the benchmarks for every piece of the system, such that we don't have to do fixes, or we don't have to do rollbacks, right, as much. So the benchmark testing was pretty extensive, I would say. And like I said, like we also had simulation environments, things like that, to basically make sure that we had very rigorous testing. And also before, like, as the product manager, you know this, like you don't just release to everything in one go, right? Like you do release in stages, where you first in you basically release to a small set of robots, and you make sure that that works, that reaches all the metrics. You make it go through challenging scenarios, and then only you release. So yeah, basically I think that the testing was pretty good.
Yeah. So again, Jadu, this is great. One of the things which, when we talk about production in the real environment, right, and given this is a robot on the sidewalk where there are people, there are pets, there are all sorts of other objects as well. One thing which kind of comes to mind is like all sorts of nuisance which can be created. Like say people could like just sheer misuse, like kind of like ill treating the robot. So there's two kinds of problems that I can think of, right? One is how does the robot ensure safety of the package which it is containing and the unit which is the robot itself, and the other or the more important part of this is like how does the robot ensure public safety, right? Even when you are training all these algorithms and you're doing the object tracking and perception, what if it actually ends up, say, harming an individual or a pet or something of that sort, right? So can you talk a little bit about that, please?
Yeah, of course. So I think, first of all, with package misuse, like this is nothing to do with me, in the sense that this was a very hardware solution where you ensure that nobody can unlock the robot in any circumstances unless they are authorized to do so, right? Which would be the people who are putting the packages, and then someone who's trying to access once their package reaches their doorstep, right? And there are similar, like as you can see, several authentication solutions that exist today in the world for that, right? So we did not have a problem with that. We luckily also did not have a problem with robot being misused or basically being mistreated, right?
Hmm.
But I will say, like, that is vandalism at the end of the day, right? And
Yeah.
to some extent, if someone, it's a water cooler sized robot running around in your neighborhood, and if someone wants to misuse it, like mistreat it or like vandalize it, there is also not that much you can do, right? And I also believe that morally that is the right thing to do, because considering your next option, which is the safety of people around you, right? So what can you do in this scenario, right? Like,
Hmm.
what you can do is get the robot to run as fast as possible, even if you have systems that can sense danger, quote unquote, right? But like, then you're jeopardizing other people's safety if you're basically just blindly running, right? So you always want to basically, it is okay if the robot is harmed as long as nobody else is harmed.
Yeah.
So that is something I would say, like, you're pretty helpless in that scenario. But we did not have those issues, luckily. But like, as the robots scale, as people, like, I have seen videos with other companies. Like, we are not the only company that does delivery robots, right? Like, there are other companies that do it, and there are videos that you can see online of on Twitter and stuff that we've seen, where yeah, these sort of things happen. But it's more of a moral question, right? What is the right thing to do in that scenario than
Yeah.
engineering one, right? Um,
Yeah.
then the second question is, how do you ensure public safety, that you don't harm anyone? And that's an engineering question. And it's more interesting. So I think the way to go about it is, you have to have several layers of safety solutions. Like, just having relying on one is not enough, and we did, right? In the sense that just relying on AI systems is not enough, as we have now. AI systems are hugely popular. They used to be a niche till only a couple of years ago, that only tech people use, but now everybody uses. And as we know that they hallucinate, right? And they make up stuff, right? Like, as we have seen with LLMs recently, like, it'll just make up stuff. So they can often lie, and very confidently so. And like, computer vision systems and stuff are no different. So you need classical systems as backup, right? Like, basically fail safes, to make sure that when you're, so you need layers of safety, and we did have that. And safety is always on the side of one thing, one advantage, huge advantage that you have as a sidewalk robot that self-driving cars don't have, is you can stop in most scenarios and you're fine.
Hmm.
So if you're crossing a road, you cannot stop, right? But like, that is only 5% of your all navigation. 95% of the time you are on a sidewalk, You can slow down, you can stop. You have the luxury of stopping, and that is the right thing to do, right? And also, you can go slower as long as when there are dynamic things around you. So you have that luxury. You don't have a speed limit to maintain,
Yeah.
right? Things like
Yeah,
so. Yeah,
that's an important one.
but
Yeah.
yeah,
Yeah.
I was sorry. I was just going to say that you need to have several layers, but yeah,
Yeah.
sorry.
No, no, no. Again,
Go.
of course, that's something which is critical, right? Like
Yeah,
basically, as you say, in public safety terms, having several fail-safe layers is what you have to build for, and that is
yeah,
critical. Um, all good. So, last question before I just wrap up. Any eureka moments, Jatin? Like something, and it could be extremely tiny or big, whatever comes to mind, right?
yeah, yeah,
Something you
yeah.
shipped which go like, oh wow,
Uh,
you know?
yeah, yeah. This is more for the team, less for me. But like I said,
Yeah.
it was huge. Is like when we basically moved to these latest transformer models, right? The performance bump that we saw was amazing, and like especially seeing the robot work in scenarios which are really obscure and really strange. Like for example, I'll give an example where basically your small robot, there are plenty of huge trucks in the US. If you have been here, you have lived here for a while, Shreyas, which have really shiny bumpers, right? So you can see the robot can see its reflection. You can see the purpose reflection, and
Yeah.
seeing your things work in those scenarios, seeing like it work as well, or the perception system being classifying scenarios which you honestly didn't think of, right?
Yeah.
When you were designing it, but just with the sheer amount of data and the tools, yeah, seeing those things work, yeah, quite
Nice.
heartwarming.
Nice. Uh, that is great. So, Jatin, as I said, I'm just going to wrap up with this. But there are a bunch of budding, aspiring engineers, people who want to build great things, right? Who are essentially watching this video. So, any piece of advice you want to share with them, or you have in general, or something you would tell your own self, like say, I don't know, 7 8 years
Yeah,
ago, right? Like
yeah,
this is something which you should do to be where you are right now.
yeah. Again, like all my advice is anecdotal, right? And I'm still learning, young in my career, so like take it with a grain of salt. But yeah, I think in general for ML and computer vision, I would still say that like there is a lot of benefit in digging deep and not, in my opinion, and there is more joy and not doing the flashy stuff that's shiny right now. Like right now
Hmm.
in ML and AI, and even the headhunters who reach out to me all the time, right? Like I can see it. The idea there is that basically, like right now, LLMs are in fashion, right?
Yeah.
So, and it is fairly easy to use APIs to quickly fine tune an LLM to get it to the most amazing things, and the tech is great. But like, if you want to, I believe, build a career in this, it is important to spend time with the basics and like learn the basics, because the basics build an intuition that finally helps you push the state of the art, right? Like make whatever's the best thing a little bit better is where like the eureka moments happen. And and that intuition takes time to build. So like quickly getting flashy results is easy, but I don't see it as a long-term career path.
Yeah. No, those are all great pieces of advice.
Yeah,
I definitely second a lot of and all of them. So just kind of like reiterating. So don't run after shiny stuff. That's your number one.
yeah,
Learn the basics. Be very close to that. Get to the frameworks and the foundation. And thirdly, make things a little better, and that's where you learn a lot more. Right.
yeah.
All great pieces of information.
Yeah. Yeah, I
Yeah.
think like finding a niche essentially encapsulates all that. Like you need to find a
Yeah.
niche and try and know everything about that niche.
Yeah.
Okay.
Yeah. Totally. All right. So, Jatin, thank you so much for being with us today.
Thanks.
This was a really, really educative piece of podcast that we have done. I definitely learned a lot. I've never dealt with robotics personally, so this was very close to my heart. Right.
Yeah.
Thank you for joining us, and I'll see you and some other time then. Okay.
Thanks a lot for having me. Really enjoyed this. Thank you.
Cheers. Take care, Jatin. Bye. So that was our conversation with Jatin. Jatin was a software engineer at Amazon Scout, which is a delivery robot by Amazon. We learned a lot of things about how robotics is done, what kind of teams robotics companies have to have, how the split between hardware and software work, and the list goes on. But what kind of stays with me is the last thing which Jatin mentioned. Like, if you really want to have a career in this industry, in robotics, excelling in machine learning and AI, the three things which you should really do. Number one, make sure that you're not always running after the shiny stuff, whether that's GPT or LLM or whatever new thing which might come. Just make sure that you're not just running after the shiny stuff. You may have an interest and you should totally look at that, but do not do just like blindly whatever, right? Secondly, make sure that you are working a lot on the basics. So you clear your foundations, you make sure that you have a very solid grasp of what the foundations are in any subject for that matter. And thirdly, please, please, please only think about how do you make something slightly better. Because only when you make things a little better, you can think about how do you make it much better and bigger, right? And that's step one for building it big. So with that, that was another episode of Building It Big. Thank you again for joining Jatin and myself. We had a great time talking about robotics. You know the drill. Like, share, subscribe. Until next time, see you.